everyone, welcome to our channel. If you like this video, you can watch, share and subscribe. So here, today I would like to start about Newton's rings experiment. So here, Newton's rings experiment is best example for evidence of the interference pattern. So in Newton's rings experiment, some of the bright and dark fringes pattern can be obtained. So by using the concept of principle of superposition of waves. So here in this experiment, here we are taking sodium vapor lamp. The light waves are coming from the source, which is incident on glass plate G. So here the glass plate G is inclined at an angle 45 degrees arrangement. So here some of the incident rays are focusing on the convex lens attached to the glass plate. So here these incident rays are focusing to the lower surface of the lens and the upper surface of the glass plate. So some of the light rays are reflected on the lower surface of the lens and the remaining rays are transmitted on the top surface of the glass plate. So here, like this, number of reflected rays and number of transmitted rays are generated in between the air film formed in between lens and the glass plate. So here, the air film is formed in between lower surface of the lens and the upper surface of the glass plate. So here, these reflected rays and transmitted rays superimpose to each other and produces interference pattern on the screen by viewed through the traveling microscope. Here M is the traveling microscope. So S is monochromatic source, G glass plate. So here glass plate is arranged in 45 degrees arrangement. So these incident rays focusing on the lens, plane of convex lens L and glass plate G. So here air film is formed in between plane of convex lens and the glass plate G. So here like this, number of reflected rays and number of transmitted rays generated in between lens and the glass plate. So here according to superposition concept, any two reflected rays or any two transmitted rays are generated, and based on interference concept, these reflected rays and transmitted rays superimpose to each other and produces circular bright and dark fringes. So these circular bright and dark fringes can be viewed through the traveling microscope M. So here this circular beautiful bright and dark fringes pattern is called Newton's rings. So here Newton's rings can be observed through this experiment based on the concept of interference. So interference based on the principle of superposition of waves. So here any two reflected rays means one crust, any two crusts. So one crust of one wave and another crust of one wave. So here like this, any two crusts or any two troughs superimpose to each other and produces constructive interference or bright fringe pattern. So similarly, any one crust or any one trough superimpose to each other and produces dark fringe pattern. So this phenomena is called destructive interference.